Hello, Year 5s, and welcome to Maths on this lovely Thursday morning. Hope you've had a restful sleep and you are ready to tackle your maths today. I've been really impressed by the maths that's been sent to us. Don't forget to send your work to us at year5@theprimeracademy.com. A reminder that if some of this work is too challenging for you, please give it a go first. Don't just think, oh, I can't do fractions and switch off. Please go and try it, and if you really are struggling and you're giving it 100%, then go and look at the Year 4 work and see if you can be doing the Year 4 maths videos, okay? Right, so we're going to be doing our fast 6 today, 6 questions. See if you can do them as quick as possible, and then we'll mark it in a moment. So pause your video and give that a go. Right, let's see how you've done. First of all, our first one is our division. So bus stop, writing the number inside, and then putting our number 4 there. Right, 4 goes into 1, I can't do, so I'm going to put a 0 in the place there to represent it. Okay, I'm not going to throw the 1 away, I'm going to regroup it. 4 goes into 15 3 times, and 3 times 4 is 12, so 15 minus 12 is going to be 3. 4 goes into 32 8 times exactly, and 4 goes into 8 twice. Your answer is going to be 382. Okay, remember, if you are struggling with your division, it is important that once you have finished a maths lesson, not doing it as a maths lesson, but when you have finished your maths lesson, to go and do hit the button or any one of those apps that we've given you to go and practice your times tables, okay? Please do not do times table as a maths lesson. All right, that needs to be an extra bit of work for you to be doing so that you can be understanding both the work that's happening in class and making sure that you understand your times tables. Right, something times 10 gives me 98. Now, if there's a missing number at the beginning, we do the inverse. So the opposite of times 10 is divide 10. So I'm going to say 98, and when I'm dividing, I'm moving my number to the right. Now, if they don't give me the decimal goes at the end. Okay, and I'm going to move the number once because there's only 1 0. So I'm going to move the 8 once over. I'm going to move the 9, 1 bunny hop over, and I'm going to make sure that I bring down this decimal so that my decimal is in my answer. Okay, it's very important that you don't leave out the decimal, otherwise you're going to be writing the number 98 again. So 9.8 is my answer. Right, 11 times 11 is our straightforward multiplication, 121. 8 minus 11, again, draw your number line, start with 8. Whenever you are subtracting, you are moving to the left. So you're going to bunny hop 11 times, and the number you're going to land on is -3. Okay, 3.8 times 9, again, making sure we set out our work neatly. 3.8. multiply by 9, making sure as well that I am timesing this number, that I'm not going to put the divide. Not that you know how to divide a decimal, but making sure that you're not making any silly mistakes here. Right, and we do our normal multiplication, short multiplication. 9 times 8 is 72, so I put the 2, carry the 7. 9 times 3 is 27. 27 plus 7 is going to be 34. And what must I not forget? And this is a very silly mistake that many of you make, and let's hope that it's not going to be made at home. So what must I do now with the decimal? Right, I've got one number after the decimal here, so I need to count one number and then put my decimal in. So my answer is going to be 34.2. And the last question, I've got a missing number in the middle, so I'm going to do a subtraction. And now whenever we do a subtraction, we must make sure that the bigger number goes on top. So I must make sure that I am writing the big number, and I've copied it down. Oh, my 3 went a little bit funny there. And then underneath, place value, making sure that all my digits align in the correct column. All my ones, tens, hundreds, thousands. Right, and now I'm going to subtract. 3 minus 4 I can't do, so I'm going to borrow and then regroup. 13 minus 4 is going to be 9. 7 minus 6 is 1. 2 minus 3 I can't do, so I'm going to go borrow. And I'm going to regroup. 12 minus 3 is 9. And 8 minus 7 is 1. And that is my answer for number 6. So hopefully you've done really well with your fast 6. If there's anything that you're struggling with, go and see if you can do it again and correct your mistake so that you are learning from your mistakes. Okay, it's very important that you are learning. Okay, and we all make mistakes. I make loads of them, as my class knows. But the most important thing is that I learn from them. And that is the message that I wanted to get across for you today. So let's have a look at our big question of the day. It says, I have one whole pizza and I have divided it into fifths. Okay, you can see there that I've divided up the slices. There are 5 slices. How can I write this whole pizza as a fraction? Have a think, write it down, and then if you need to pause the video, you can. Otherwise, let's see. Right, I've just said that I've divided my pizza into 5 equal parts. So I know that my bottom number needs to be 5. Now, how many times can 5 go into another number, which is what I'm going to write as my numerator, to give me 1? And hopefully you would have said 5. And we touched on this the other day as well. So 5 goes into 5 once, and therefore, whatever the bottom number is, the top number has to be exactly the same to give me 1 whole. So it's really, really simple. All right, if I wanted to make up a fraction, and let's say I have a chocolate bar and I've divided it into 3 equal parts. It's not very equal, but you can understand. 3 equal parts, right? And that is 1 whole chocolate bar. And I want to know what would that be as a fraction. I would say, right, I've divided it up into 3. And then therefore the top number must also be 3. Okay, so whenever we're looking to create 1 whole, whatever the bottom number is, must be the top number, okay? Whatever our numerator and denominator are exactly the same. So we're gonna look at creating, counting on a number line, okay? So we are gonna be looking at counting in fractions today. So first of all, we need to decide what am I counting in? Just like with normal numbers, if I'm going 1, 3, 5, 7, 9, what am I doing each time? I'm adding 2. This is no different, except now we're using fractions. So what am I counting in if I'm going from 1 and then I get 1 1/3, then I get 1 2/3, then I get 2, then I get 2 1/3. So what am I adding each time to my bunny hops? And I'm adding 1/3. So pause the video, see if you can do those 2. Otherwise, if you need some practice, we can do them together. Otherwise, see if you can do them on your own. Right. So I'm now going to add 1/3 to 2 1/3. So I'm going to keep my whole and I'm going to add another third. 1/3 plus 1/3 is going to be 2/3. And then I'm going to add another 1/3. Now, why will it not be 2 3/3? Have a think. And hopefully you can tell me that 3/3 is actually a whole. So if this 3/3, it makes 1, and I've got 2 whole already, and I've got another whole. What is 2 plus 1? 3, okay? So you will never, ever, ever see a mixed number with a whole number and then a fraction that looks exactly the same with the bottom number and the top number being the same, okay? So it's very important that you're not making that as a silly mistake, that when you're counting, you're making sure that if you do land up with the numbers that look the same, then you must know that that means 1, and you add 1 to your whole number. Right, see if you can do this one on your own now. So pause the video and have a go. Okay, let's see how you did. Hopefully you just gave it a go. That's all we expect. We don't expect you to get it right all the time. Okay, so let's see. Hopefully you just done your best and you've given it a go. So first of all, I need to decide what am I doing to each of these numbers to get the answer. So I'm going 3 4/5, 3 3/5, 3 2/5. So now I'm subtracting 1/5 each time. So you would keep your whole number 3, and I'm going to say 2/5 minus 1/5 is going to be 1/5. Right, now I'm going to take another 1/5 away from it. So if I take 1/5 minus 1/5, I'm going to have nothing. So I'm just going to have the whole number, 3. And now I've got to take another 1/5 away from it. Okay, so I'm going to be left with 2 4/5. And a good way to go and check your answers is to go and do the inverse, especially when you're subtracting. I think adding is a lot easier, but when you're subtracting, sometimes we make silly mistakes. So if we go backwards now and I add the fifth, so I'm doing the inverse, I'm going to say 2 4/5 plus a fifth is going to give me 3. 3 plus a fifth is going to give me 1/5, and then the rest carries on. And 3 1/5 plus a fifth gives me 3 2/5, and therefore I can be quite confident that that is correct. So when you're checking your answers, you can do the inverse, because I think adding is sometimes a little bit easier than subtracting. Right, let's have a look at this number line, okay? I'm counting in what? What am I counting in here each time? And now some of you might be looking at this and thinking, this doesn't look right. These are all 4s. All my denominators are quarters, and then suddenly I've got a half sitting here. Is this correct? And now think about your knowledge that we've been teaching you this week about fractions. I think we did it on Monday and Tuesday. What types of fractions were we learning about on Monday and Tuesday? And hopefully this jogs your memory a bit. So hopefully you've realized that this is an equivalent fraction. So if I had to make this an equivalent fraction, it would be 2 quarters, because 2 times 2 is 4 and 1 times 2 is 2. So I'm using my equivalent fraction knowledge. So this means that they are exactly the same amount. I haven't changed the amount. If I eat a half of a pizza and 2 quarters of a pizza, I've eaten the same amount of pizza. Okay, so now I've got a quarter, 2 quarters, 3 quarters, 1 1/4. So what am I doing each time? I am adding a quarter. So if we had to continue this number line, what will be the next one? 1 2 quarters. Now, they have made a very silly mistake as well in this. And can you find that silly mistake for me? If we're counting in quarters, what is the silly mistake that has been made here? And hopefully you would have realized that you're counting in quarters each time and you land up here, and now suddenly you've only got a quarter, but you already had eaten 1 whole pizza. And if you add a quarter to a whole, you've eaten 1 whole pizza plus another slice, a quarter of another pizza. So therefore, their missing whole numbers needs to be 1 1/4. Okay, so making sure that you're looking very carefully at your number line, looking for equivalent fractions, okay, numbers that are exactly the same amount. All right, there's no difference to them. So looking for numbers that look different but are the same, okay? I can make that into an equivalent fraction, and therefore I know I'm counting in quarters, right? And I can also look out for silly mistakes. And if I've got my whole number, I will carry on with my whole number, adding it. So what can you work out from these 2 questions, okay? Let's see if you can do them on your own. Some of you might want to challenge yourself to have a go at answering them on your own. And then if you do need a little bit of help, you can just continue watching the video. Nice little cup of coffee for me this morning. Get my brain working. Okay, so first of all, we need to find out what is this sequence increasing by. So increasing means I'm obviously adding. So that gives me a clue already what I'm doing. I'm adding something. So I've got 1, and then I've got 3, and then I've got 5, and then I've got 7. So what am I adding each time? I'm adding 2. Now I'm not adding 2 whole numbers. I'm adding 2 ninths, okay? Right? So I'm going up at 2 ninths each time, all right? Not 2, okay? Be careful. 2 is a whole number, which means I'd be adding it to my whole number here, all right? So I'm going up by 2 ninths each time. True or false? Let's have a look at this question now. Again, if you would like to give this one a go on your own, please do it. Pause the video and have a go. Those of you who just feel like you need a little bit of an extra input, you can carry on listening. Right, so first of all, we need to see this sequence below is increasing by an 1/8. So it's telling me that I'm adding an 1/8 each time, okay? Now, again, if I have a look at these fractions, I can see that all these fractions are over 8. So this one looks a little bit strange. It looks a little bit different. So If I take that fraction a half, what knowledge can we use that we've been working on in the beginning of the week? We've been looking at equivalent fractions. So can we make this an equivalent fraction that's also going to have the number 8 at the bottom? Right, so what did I do to the 2 to get 8? I multiplied it by 4. So what do I do to the 1? I multiply it by 4. So I'm going to have 4 8s. And if it's going to help you, write it next to it. So first of all, I got all my whole numbers as 4, and then I'm going to 5, and I'm adding an 8th each time. So 3, 4, 5, 6, 7. And if I add an 8th to a 7/8, I'm going to end up with a whole number adding another 1. So that would be true. Okay, so even though this fraction looks different, it is exactly the same as 4 8s, exactly the same amount, using that equivalent knowledge that we taught you at the beginning of the week. Okay, write the fraction down. What are you trying to create? You're trying to create 8s. 2 times what gives me 8? 4. 1 times 4 gives me 4. 4 8s. And then you can go and check the sequence to make it so you can make sense. And again, write it on the piece of paper, okay, so that you can definitely make sure. Right, we're going to be looking at sequencing these numbers from smallest to largest. And can you see there that I've also underlined those keywords? Very, very important that I'm underlining and I'm highlighting any key information that's going to help me to understand the question. Right, so first of all, if you would like to give this a go, you can pause the video now and have a go on your own, which I do challenge you, and I hope you do give it a go. All right, for those of you who would like to go through it with me, you can obviously just carry on listening. So I'm going to start with looking at my whole numbers first. My whole numbers are going to be the ones that are going to tell me a little bit of information first, okay? I'm going to ignore the fractions for now, and I'm going to start with my whole numbers. And I need to find the smallest whole number. Right, so here is 1, 2, 2, and 2. If I eat 2 pizzas, or if I eat 3 pizzas, which one is smaller? 2. So I'm going to start with these 3 numbers. Now I'm going to look at the fractions, okay, because all of them have 2. So now I need to look at the fractions to help me. Now, this fraction is over 4 and this fraction is over 4. So I've got quarters here and I've got a half here. So what can I do to this fraction so that I can also be in quarters? And hopefully you would have realized that I need to make an equivalent fraction. So 2 times 2 gives me 4. So 1 times 2 is going to give me 2. Okay? And now that I've got my fractions are all over the same denominator, I can clearly see which one of the top numbers is the smallest. So the smallest one is going to be 2 1/4. And I'm going to cross it out so I know that I've used it. Often, some of you leave out a number or you add it in again somewhere along in the answer. Okay, so I'm going to cross it out so I know I'm not going to use it again. Right, then I've got 2 quarters and I've got 3 quarters. Now I'm going to write the original fraction, okay, which is 2 1/2, because 2 is smaller than 3. So I'm going to write 2 and 2 quarters, original number is a half, original fraction, and I'm going to cross that fraction out, and then I'm left with this one, 2 3/4. Right, cross them out. Now I'm left, let me do it in a different color, I'm left with the 3s. Now I've got 3 1/2, I've got 3, and I've got 3 1/4. Now again, these numbers are all the same, the whole numbers, but now I've got some fractions. So I've got a half here and a quarter here, and I've got nothing here. So with nothing, I can just leave that blank. Okay, I don't need to do anything with it because there's no fraction attached to it. But now I've got a half and a quarter. So what can I do? Which fraction am I going to be looking at to make it an equivalent fraction? Okay, and I'm going to be looking at the half, because I can't say, if I looked at the half and the quarter, and I said, right, I'm going to say a quarter divided by 2 is 2. 1 divided by 2 is not going to give me 1, okay? So I'm going to look at the half, and the half is going to tell me what I'm going to be doing, and I'm wanting to get quarters. So I'm going to say 2 times 2 is 4, and 1 times 2 is 2. Right, so which one of those is smaller? Now, this one has no fractions, so I have nothing extra. So 3 is going to be my next number. Cross him out. Now I've got 3.5 and I've got 3.25. So which one would be the next smallest? I mean the next biggest. And then I've got 3.5 left. Writing the original fraction. So now I've gone from smallest to biggest, looking to see which number is getting bigger. That one is going to be smaller than that one. And so I can carry on and I'm happy. Okay. Right, can you have a look here and find the mistake? It should be quite glaringly obvious to you what the mistake is here. It was in our big question and it was part of some of our thinking today. So can you see which one of these is very much the wrong answer? So pause your video and have a go. Okay, hopefully you realize this one, without even having to work out any of the equivalent fractions, this one is definitely going to be the wrong answer, okay? Without even having to work anything out, because it only asks me for one mistake, and this one is definitely the one mistake. I don't even have to look at creating equivalent fractions with my halves, because I know that this one is going to be incorrect. And the reason why it's incorrect is because if I have 4 quarters, I actually have a whole. So this is theoretically 4. So I can't be counting 4 and 4 again. Okay, remember we never write a mixed number with a whole number and then a fraction that has both top and bottom numbers the same. That 4 quarters means that I have 1 already. Okay, so I'm saying 3 plus 1 is 4. So I've repeated myself here in counting. Right, you are now going to choose the activity that best suits you. There's going to be 3 worksheets, and then at the end of your worksheet will be your answers, all right? So you're going to choose which activity you would like to do. Please don't just do the easiest one because it's just you're just being lazy. Please try and do the one that actually you feel like you can challenge yourself and you can learn from it, especially if you have found the input quite simple and you got through those questions, then go and challenge yourself and do something a bit harder. Otherwise, you're not going to learn. So if you are doing the 2 or 3 chilies, you can fast forward to those slides. If you are going to do the 1 chili, here you go. Here are your questions. Pause the video at any time you need. I'm going to scroll down and your answers will be at the end. As I say, pause the video and then you can get going with the answers. Right, hopefully you've done really well. Here are your answers. So anytime you need to pause, click on the pause. Right, those who are doing the 2 chilies, here are your questions. Pause the video whenever you need, and then you can carry on until the end. Your answers will be after this. Right, and here are your answers. And the last one, 3 chilies. Answers will be at the end, so pause your video whenever you need. Great, so that is all from me for today. Hope you have a wonderful day. Don't forget to send your work to us, and I will see you a bit later.